Alright, scholars, time for our next set of math notes. Go ahead and put your name and your number up in the top right-hand corner, as you always do, because I know you always do that, right? And then let's label that this is Module 3. We are continuing with our Module 3 notes. Still talking about fractions. We've done a little bit with adding fractions, and we've done a little bit with least common multiples, common denominators. Today we're going to go ahead and put those two things together. So, Module 3, Lesson 4, adding fractions with unlike. So uncommon, not the same, with unlike denominators. Okay. This is lesson 4, so our Roman numeral will be 1 less than 5. Okay. Let's zoom in a little bit. There we go. Now, again, no vocabulary. We're going to kind of just jump straight into it. To add fractions. This is a key concept that I think most of you have by this point, but just to make super sure. To add fractions, you must have like the same. Okay. You must have like or the same denominators for each fraction. Each fraction that you're adding together has to have the same denominator. If their denominators are different, if they are unlike to begin, then we're going to have to fix them. Remember, you cannot compare apples to oranges. You cannot combine thirds and fourths. You'll see that in a minute. Okay. If, should say when probably, if fractions have unlike, if fractions have unlike different denominators, if fractions have unlike or different denominators, then, again, you have to change them. You have to find a common denominator. We've seen some ways to do that with models, but a more accurate way is to use least common multiple. We use LCM to rewrite them. Okay. We use LCM to rewrite them. Okay. So let's take a look. Step 1, let's see how this is going to work. Okay. Well, step 1 is just find the least common. Now, we're going to find a least common multiple. That's what it says up here. However, I'm going to write it least common denominator. Basically, just trying to be a little more specific, okay? Because we are going to be looking at the denominators. So if I give you 2/3 plus 3/4, I want to find the LCD, the LCM, again, least common multiple. I want to find the least common denominator of, well, let's look at my denominators. I've got a 3, and I've got a 4. Now, I know I keep repeating this, but I'm hoping it'll motivate you to work on your multiplication facts. If your multiplication facts are strong, you might already know what the LCM for 3 and 4 is. But we'll go ahead and list them out. Okay. The multiples of 3, we've got 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and that should be good. Again, a lot of you probably seeing it already. Okay. 4 times 1, 4 times 2, 4 times 3. Well, if you didn't see it before, hopefully you see it now. Okay. Again, there are plenty more, but I don't need to continue. I already found something that repeats in both lines. I want the smallest multiple, the least common multiple, the smallest number that repeats in both. Okay. Now this next part is where things get a little interesting. We're going to spend a lot of time practicing this. Okay. For step 2, you are going to use the least common denominator that you just found to write equivalent fractions. I think that's probably going on. Oh, no, it did fit on the screen. Okay. Use the LCD, use the least common denominator to write equivalent fractions. Now, let's talk about how this works. I've got 2 over 3, 2/3, right? But I want this denominator to be 12. That is a common denominator. That is something that is a multiple of both 3 and 4. So I know I should be able to get 3 to 12. Excuse me, 3 to 12. I need to multiply 3 times something to make it 12. Well, when we were listing our multiples, we talked about how that was 3 times 4. Anything I multiply the bottom by, I have to multiply the top by as well. So 2 times 4 equals 8. Okay. We used our least common denominator, 12, as our starting point. We figured out what to multiply the original denominator by, 3 times 4, that would give me 12. And then we just did the same thing on the top. These fractions are equivalent. 2/3, 8/12, they're equal to each other. They're the same amount of stuff. Yes, they look different. The sizes of the pieces are different, but it's the same amount of stuff. If I were to shade in boxes like we did with our models, it would look the same. It would be the same. Now, I did that with the first one. I need to do it with the other one as well. 3 over 4 is equal to, again, something over 12. I don't know what the something is yet. I know 4 can be multiplied by a mystery factor to give me 12. That mystery factor, 4 times 3, okay. So if I multiply the denominator by 3, I must multiply the numerator by 3 as well. 3 times 3 is 9. I now have 2 fractions with common denominators that I can combine. So for step 3, okay. Step 3, write the equivalent fractions, and you know how much I love this, vertically. Whoops. I guess I got so excited I couldn't write the word properly. All right, let's try that again. Write the equivalent fractions vertically. There we go. That looks better. Okay. Write the equivalent fractions vertically. It's beautiful. Vertically. Add the numerators and simplify. Okay. I had students asking about the simplification also, so you're about to see how that works. Now, normally what your problem is going to look like is something like this. You're going to have the original fractions, 2/3, 3/4. We're adding them together. Okay. Now, Whether it looks like that on the paper or if you just have to write it that way on yours, you're going to start by writing vertically. I'm going to extend out my little bar quite a bit because I will need the space to write my equivalent fractions. We already talked about how 2/3 is the same as 8/12. We know that 3/4 is the same as 9/12. Okay. Now, a few notes. And we're going to write this one in bold. Only add the numerators. Okay. I keep saying the denominators are like labels. They're like the units. Okay. We don't add inches to each other. We don't add feet. You don't have inch, inch, or foot, foot. You just add the number before them. So in this case, only add the numerators, please. Only add the numerators. Now, another key point. Bring the denominator down before you start. This is just another way to make sure that you don't accidentally add them together. So if this is 12ths, skip a line, that's where the numerator will go. Your answer is going to be 12ths as well. Okay. 8 plus 9 hopefully is fairly straightforward for you. 8 plus 9 is going to be 17. Now this will happen every once in a while, and again, I had some friends ask about this in class. Okay. If, it won't happen all the time, but if the fraction is improper. Now, again, I think we discussed this, but just as a quick refresher, improper means that the numerator is larger than the denominator. That should not normally be the case. If the fraction is improper, rewrite as a mixed number. It's a mixed number because it is a mix of a whole number and a fraction. Okay. So, for those of you who would like a little refresher on that, let's talk about what that means, and then we'll be just about done. Okay. If I have 17 over 12, 17 is obviously bigger than 12. The numerator is larger, so it is an improper fraction. I look at this, and I look at my denominator, and I think to myself, if the denominator is 12, then that means I need 12 to make a set. Maybe I'm trying to combine my action figures together into groups of 12. Maybe I am trying to sell bags of 12 marbles. Whatever it is, every time I can put 12 together, that means I have a complete set. Okay? So, looking at this, knowing that I need 12 to make my set, I look at my numerator and I think, okay, I've got 17 pieces. I only actually need 12 of them to make the set, so I am going to remove the 12 that make the set. Still just kind of mentally thinking here. Okay? When I take that 12 out, that 12, there we go. Love my arrows. That 12 is going to be one whole. I made one complete set. Now, I still have some things left over. 17 minus 12 is 5. That means I've got 5 little pieces left out of the 12 that I would need to make a second complete set. We'll practice a lot more with mixed numbers, but I'm hoping you saw some of this in 4th grade. Ultimately, this is our answer, 1 and 5 over 12, 1 and 5/12. We will practice all of these things in class, as a group in class. If you have any questions, let me know. We'll talk about them then. But for now, that's it. Thank you, ladies and gentlemen. I will see you in class.